In this lesson, we will try to understand concept of dimension and derived unit. First, let us see the difference between property and dimension. This will give us an understanding about the concept of dimension when we deal with measurement. Property is what is being measured. So, even in last tutorials, we said that when we measure, we basically measure a property of an object. So, the property is a characteristic of an object which can be measured, whereas the dimension is a fundamental nature of the quantity. Let's make it more simple so as to understand the difference between two concepts. Dimension is independent of unit. When we say length, suppose we are measuring length, we will say the dimension of length is, say we denote it with L. Whether it is measured in meters, centimeter and feet, length will remain length. So length we can say is a dimension, but when we give a numeric value, we say length is 1 meter or 100 centimeter. So dimension is the fundamental nature of quantity. In this example, length is the fundamental quantity, but when we define the property, we will add the units. We say it is 1 meter or it is 100 centimeter. So this defines the property of an object which we are measuring. To make it clearer, we can say that the relationship between dimensions can express different properties. So, for example, if I say length, the distance between 2 points, so this is the length, this is one dimension. But if I multiply length with another length, if I multiply it, then I'll get a property of area. I can say this is a smaller length, so I will say width. So I can say length multiplied by width, I'll get area. So when we multiply, in this example, we are multiplying two dimensions, length and length, or length and width, we are able to define a property called area. When we are multiplying three dimensions, length, width and height, again the dimensions are basically length only. Width and height are also length in different directions. We are multiplying length, width and height, three dimensions, we get concept of volume. Or we are dividing two dimensions, say mass divided by volume, we get density. Distance or length divided by time, we get concept of speed. So we have seen that when we multiply or divide these dimensions, we get to measure different properties. We are able to define and measure different properties. Let me show you some examples. For example, area. Now area, we have seen it is a product of two dimensions, which is length multiplied by length. Now smaller length we will call as width. So length multiplied by width will give us a property known as area. If I change the one dimension, so this is my length, the bigger dimension, bigger length, we call it length, smaller length, we call it width. And when we multiply the two dimensions, length multiplied by width, we are able to get a concept of area. We are able to measure area. So length will have a unit, meter, for example meter, multiplied by another dimension, again meter. Meter into meter is meter to the power 2, which is called meter square or square meter. So this becomes a derived unit. It has been derived or obtained from these two dimensions. So this meter square is a derived unit of measurement, and it is being used to measure the property of area. Now in case of 3 dimensions, now in this picture you will see there are 3 axes, x, y and z. These are the direction in which a particular dimension is measured. Now if we see this object, this is in direction x and this is direction y. The direction z, which is the height, we don't have in this case. It is a flat surface. So we will get a concept of only 2 dimensions, length and width. So we will be able to measure only the area of this object. When we multiply the length and width, we will get property as area. But if I add one more dimension, for example, if I close this figure, if I just close it, it becomes a shape of box, and there is one more dimension which is in the direction of z. So this is your height, this is your width, this is your length. So you are now multiplying 3 dimensions, and when you multiply 3 dimensions, you are able to conceive, you are able to measure a new property which is called volume or space occupied, the space inside this box. So length will have unit of meter multiplied by meter multiplied by meter. So now when meter is multiplied 3 times by itself, we can express it as meter to the power 3. So it is called cubic meter. So cubic meter or meter cube gives us one more unit. Again, this is a derived unit. So this is also a derived unit. And this is derived unit for measuring volume. In the same manner, we can measure a property called density. Again, it involves 2 dimensions. One is mass, other is volume. And now we are not multiplying, we are dividing 2 dimensions. Mass divided by volume. So mass is shown by these molecules, blue molecules. And if I change the volume, volume is in the denominator because it's a dividing line. Suppose I change the volume, I've increased the volume of this space, this say cylinder. You will see as I increase the volume, mass is same, but density is less in this case. So we can use unit of mass, which is for example gram, divided by unit of volume, which is say cubic meter as we saw, or liter. So we can get another derived unit, grams per liter, or grams per cubic meter, or kilogram per liter, or kilogram per meter cube. All these are derived units for measuring density. In next example, we can see example of velocity. Velocity is distance divided by time. So again, 2 dimensions are divided. First dimension is distance, which is meter. So unit of this dimension is dimension of length, meter, divided by time, say second. So again, this is a derived unit. for measuring another property, which is speed. Now, as an exercise, you think about these properties: force, acceleration, pressure, power, energy, and think in terms of dimensions. So what dimensions and relationship between dimensions, whether you're multiplying 2 or 3 dimensions or dividing so as to define this property. So write down the dimensions over here, as we did in case of density and speed. Write down the dimensions, whether they are being multiplied or divided, and that will give you the different derived units. Okay, you can pause this video here, note down these property, try to find the dimensions involved, and then you will be able to find the derived units.